easily constructed by the simple mathematics, even the parallel to the in the both sides, or you can use the function this curvature formula is you can definitely use nx derivative of this by this ny, and you can add this thing with the thickness whatever you wish to assume the thickness, you can write it. So you can see that I can how I can implement this function. So here thickness is mentioned as 1, so 1 meter is the thickness. So I wish to construct first the function first, so I go back here and go for the function. Yes, so I write the function name as n of x. Expression I wish to write here, the argument is now t. The expression is basically the minus of derivative is written like this, d of some function comma the basic argument, which argument with respect to what you are going to differentiate. So dy by dx, you mean that you are using the y function for writing nx comma t. But what I forgot to mention the argument of this. So this is the important thing you should keep in your mind. Second is the square root of what? Square root of, you can see here, square root of x dx square plus dy square. Okay. Second right is here d of x underscore function derivative t, and you can say cap this plus the same thing I'll going to okay. Now you should keep check the parenthesis, this is closed here and this is closed here, the square root function is closed here, and this is a rest of thing is fine, it is referred to t. So one function is defined, and similarly I can copy this function for my new function. New function is basically a new analytic function, so you can write n of y. Function name, function label, keep it the same, for otherwise you can change it yourself. So it's easy if you keep it the same. So you can change it by dx and with the positive sign. So d, okay, this should be should not be same. This is actually the positive with x as this. So okay, and the argument should be t. So this is all about the declaration of the function. Now I go for the another parametric curve which I wish to construct. Go for this again and go for the parametric curve. Yes, this is the name you wish to write, use as a t. Obviously here you wish to use theta 0 and theta basically final. The curve which you wish to use now is this function, this new x1 y1. So you can write this a1 b multiply t cos of t plus nx of t and y. So if I wish to build it, yeah, the problem is the initial thing. So here I have used theta 0 and here I have used also a theta 0. The parameter is same, the function is, if I wish to change the value with the minus, let me check what is the difference. Yeah, it is okay, because you are in the left hand or the right hand, you have to be keep in balance. But problem is that this parallel is not good. If you wish to change the basic property of the parameter, you can go back You can make this turn as 10, you can make this as a 4, and accordingly calculation will be changed. You can go back, function will automatically change, and if you wish to go for the geometry, and you can see that it will change. This is the basic turns and the spiral of this, and you can say that the turns are very large. You go back here and you can make the turns even lesser, like if I wish to use 3 only and go back here and build it again. Yeah, so this is something you can easily handle, as in the COMSOL it's a basically GUI and it automatically change everything, and you can go back whenever you wish to want. So this is type of spiral. I wish to make it in a 3-dimensional spiral. The problem is that you have constructed only the 2 lines. It's a 2 parametric line. You need 2 more lines to join this, and now the problem is that the point, if you use the mathematical function, you can again use the mathematical function to join this if you don't want this. So there is another thing that you can do. Rather than using mathematics, you can manually handle everything. So you can go here, line option, click it, and here you can click one and just go to the another corner and click and press the right click. So then you can see that the line is been constructed. But the important thing you should keep in mind using this option, that you should locally zoom this. It should be connected properly. Yeah, it is connected. And if you go to another site and you wish to zoom it to see that whether it is connected properly or not, if it is not connected, then it's the problem that you will not able to construct the 3-dimensional geometry. So I'll zoom it to the extent that it is connected, and similarly I can use the Bezier polygon option to the another end. I go to this end. So better option is the locally zoom it. So then I click on the line and go to this point, click it, then go to this point, click it, and press right click to stop it. So I think this is also clear that, yeah. And similarly I will check if it will not give the 3-dimensional geometry, then obviously this may be the one of the reason that it is not been connected properly if you are using the manual option. Otherwise, using mathematics, using proper function, even the correcting, this such a problem will not be occur. Anyways, the next thing is that I wish to extrude this geometry and make it the 3-dimensional geometry. So firstly, what should I do? I go here and use the transformation, or you can say the conversion, convert to solid. When I use this option, so I wish to convert this all 4 things into a solid. So I'll build it. So you can see that this is now been converted to the solid. But when you go for this 3-dimensional view, this is actually only the work plane. You are working on the only a one cross section of the work plane, 3-dimensional geometry. So it's just a work plane, and just if I wish to construct or assemble this, so what I wish to use 3-dimensional option is the same, just extrude it. So extrude means that you are just extruding the 2-dimensional geometry and you construct the 3-dimensional plane. Just click it and build it. Sorry, just click it. Yeah, this is now here. Now click. So this is your 3-dimensional. The problem is that the rough surface. So what do you wish to do? You have to use this union option and click it. This will create the smooth curve. So finally, so this is how you can construct a spiral type of geometry. And this is the three-dimensional Archimedes spiral. You can zoom it, you can check it. Even the option is that you can go for the transparent option. You can see the edges of this. There is a, I think that total 6 edges for this spiral, and if you are using any heat transfer in solid problem, you can give this edge as some heat and you can use it. So this is very easy to use. But firstly, the important thing that if you are not able to construct a good geometry or proper geometry, obviously your simulation and calculation is not correct. So this is all about of construction of 3D geometry, like spiral type of complex geometry. And similarly, you can construct any geometry. If you wish to construct more, you can write to me on my email ID Scientific Rana, and you can subscribe to my channel Scientific Rana for more upcoming videos. So thank you very much. Have a nice day.